All right, today we're diving into something that sounds simple, but is actually, kind of brilliant in machine learning. It's called early stopping. And it all boils down to one big question. Seriously, think about it. You tell a machine, go learn, but how does it know when to stop? I mean, when does that really useful learning just turn into plain old memorization? It's a great question, and the answer, well, it's a lot more straightforward than you'd expect. So, the whole reason we even have to ask this question comes down to this classic problem in machine learning, something called overfitting. Basically, it's what happens when a model gets, well, a little too good at its job for its own good. Okay, let's think about it like this. Imagine you have two students getting ready for a big test. The first student actually tries to understand the concepts. They learn the why behind everything so they can tackle problems they've never seen before. Then you've got the second student, you know the type. They just memorize the answers to every single practice question. Sure, they might ace the practice test, get a perfect score even. But what happens on the real exam? They're totally lost. The goal always is to learn the pattern, not just memorize the noise. And that, right there, is the trap of overfitting. The model becomes absolutely obsessed with the training data. It learns every little detail, every quirk, even the random, meaningless stuff. And in doing so, it completely loses its ability to handle anything new. It's the classic can't see the forest for the trees problem. So, what do we do about it? How do we stop this from happening? Well, you could throw a lot of really complicated methods at it, for sure. But one of the most powerful tools we have is also one of the most elegant and simple. And that's where the hero of our story comes in: early stopping. And really, the name says it all. The idea is just so simple. Instead of letting the model train forever or for some fixed number of hours, we just watch it and we hit the brakes right at that perfect moment, that sweet spot, just before it crosses the line from learning into memorizing. How does it work? Well, it all comes down to having an impartial judge. See, the system doesn't just grade the model on its own practice questions. It has this separate observer, this third party, that's watching to see if the model is genuinely getting smarter or if it's just getting better at, cheating on the test. Okay, so that's the big idea, the what and the why. But how does this actually work under the hood? Let's get into the step-by-step process. The whole trick, the secret sauce really, relies on something called the validation set. It's pretty clever. Before you even start training the model, you just take a chunk of your data and hide it away. You put it in a lockbox. The model never gets to see it, never gets to practice on it. This becomes our judge. So here's the playbook. It's super clear. Step 1, you split the data. Easy enough. Then, step 2, you let the model train on its data. But all the while, we're constantly checking its performance against that hidden validation set. And what we're looking for is that one specific moment, the turning point, the exact instant when its score on the validation set stops getting better or maybe even starts getting a little bit worse. And when that happens, bam, we stop the training. And this part is absolutely crucial. We rewind the model back to the state where it performed its absolute best. Now, of course, it's not quite as simple as just stopping at the first little hiccup. Performance can fluctuate. So we need to fine-tune the rules a bit. How do we make this whole stopping process a bit smarter? Well, the main knob you get to turn is a parameter, and it's perfectly named. It's called patience. Basically, this just tells the system how many training cycles to wait after the performance stops improving before it actually stops the training. Think of it like a buffer, right? It keeps you from overreacting and stopping everything just because of one tiny random dip. And this is where things get interesting, because it's a real trade-off. On the one hand, if you have too little patience, you risk stopping way too early, before the model has even had a chance to really learn what it's doing. But on the other hand, with too much patience, well, you might wait so long that the model has already started overfitting by the time you hit stop. Finding that perfect Goldilocks zone, that's a big part of the art of this whole process. There are a few other key ingredients here, too.
For instance, you have to decide what you're even measuring. Is it accuracy? Is it error rate? You also have something called minimum delta, which is just a fancy way of saying an improvement doesn't count unless it's bigger than some tiny amount. And super importantly, you've got model checkpointing, which is just saving the best version of your model as you go along.
Okay, so we've gone through the mechanics, but why is this seemingly simple idea so powerful? What's the big payoff here? Let's get into it.
Because when you add it all up, the benefits are just huge. I mean, look at this. First and foremost, it tackles overfitting head-on. That's its main job. But it also saves a ridiculous amount of time, energy, and money because you're not running all these useless training cycles. And the end result? A model that's just better at its job in the real world. It even makes other parts of the tuning process simpler. It's an incredibly smart, adaptive, and efficient way to do things.
And let me be clear, this isn't some obscure trick that only exists in research papers. No way. This is a real workhorse of the industry. Early stopping is used everywhere, in some of the most cutting-edge fields you can imagine. We're talking computer vision, natural language processing, even financial forecasting.
And that's exactly why, for anyone who's actually building these systems in the real world, where time is money and performance is everything, early stopping isn't just a nice to have. It's an absolute necessity. It's a fundamental tool in the toolbox.
It's pretty amazing, isn't it? It just goes to show you that sometimes the most powerful, game-changing solutions are the ones that are beautifully simple. Which really just leaves me with one final question for you to chew on. What's the next simple idea out there that's going to completely change how we do things? Thanks for joining me.